All right, we're doing 10.2 lecture video C. These are rules for exponents with rational exponents. Remember, these are the rules for rational exponents. When you multiply powers, you add the exponents. When you have a negative exponent, you put it under 1 to make it positive. Whenever you raise a power to a power, you multiply the exponents. Just let me double check this. When you multiply powers, you add the exponents. I wasn't for sure. I can't remember what I just told you. However, please don't forget. Please go through these. These are the same rules for exponents that we've dealt with in the past. And if you go over them one more time, it makes everything easier. So let's go ahead and start some examples. We have 3 to the 1/2 times 3 to the 1/3. When you multiply powers, you add the exponents. So on this one, my base is 3, and I'm going to have 1/2 plus 1/3. Now, when you add fractions, you got to have a common denominator. So I'm going to work over here, 1/2 plus 1/3. You got to have a common denominator. 2 and 3 are not common denominators. I know 2 times 3 is 6. So 6 is a number that both 2 and 3 can be evenly divided into. Well, to get 6, you're going to multiply 2 by 3, whatever you do to the bottom. Let me turn this timer up so I don't go too many. And whatever you do to the bottom, you must do to the top. So this is going to be 3. Same thing with 3 over here. Whatever you do to 3 to get 6, you're going to multiply it by 2. Whatever you multiply this by, you're going to multiply the numerator as well. And that's going to give you 2. Now that my denominators are the same, I got 6, and 3 plus 2 is 5. So I'm going to get 3 to the 5/6 power. Now it says simplify each expression, write the answers only with positive exponents, assume all variables represent positive real numbers. So that is all you can do. You can't simplify that because it's not whenever it's an improper fraction, you can simplify it. But if it's just a fraction, meaning the numerator is smaller than the denominator, you're not going to be able to simplify it as long as the base is broken down to its lowest prime. All right, so now letter B, it's a division of powers. When you divide powers, you subtract the exponents. So it's going to be 7 2/3 minus 4/3. And what's nice about these ones, that they have a common denominator, so that works out nicely. My base is going to be 7. 2/3 minus 4/3 is a negative 2/3. You're not allowed to have a negative exponent, so you're going to put it under 1. Okay, now I have an issue here. You're not allowed to put you're not allowed to have a radical or a fractional exponent in the denominator. If you have that, you got to rationalize the denominator. And what I'm going to do is I'm going to multiply the bottom by 7 and 1/3. The reason why I chose 1/3 is because 2/3 plus 1/3 is 3/3, which is 1. So whatever I do to the bottom, I must do to the top as well. So my numerator is going to be 7 and 1/3. My denominator is going to be 7 to the first power. You don't really have to put the 1 there, but you can. And the way I did that was 2/3 plus 1/3 gave me 3/3, which is just 1. All right, just to show you the math on that part. Now this one over here is a power raised to a power. So you want to take care of the numerator first and then deal with the denominator. So my first base is A. 1/3 times 6. 3 goes into 3 once. 3 goes into 6 twice. 2 times 1 is 2. My next base is B. So I'm going to have 2/3 times 6. 3 goes into 3 once. 3 goes into 6 twice. And then 2 times 2 is 4. So that exponent's going to be 4. Now in the denominator, I have B. There's a 1 on B that you don't see. 1 times 6 is 6. Now it's a division problem. I have nothing to do with the a squared. It stays up in the numerator. Now my B is a division problem. I have 4 minus 6. So I have a squared, b, and that's going to give you a -2. You're not allowed to have a negative exponent. So you're going to move that b to the denominator, and it becomes positive. Let's go to the next problem. This next problem says, simplify each expression. Write the answers only with positive exponents. Again, you have a fraction raised to a power, so let's take care of that first. My first base is a. I have 3 times a -1/2. So that's going to be a -3/2. My next base is b, and that's going to give you, and if you want to see what I'm doing, 3 times a -1/2 gives you a -3/2. The next one, I have -4 times a -1/2. 2 goes into 2 once, 2 goes into 4 twice. -2 times a -1 is a +2. So 2 goes here. My denominator, a, -2 times a -1/2. -2 times a -1/2. Again, the 2's cancel out. A -1 times a -1 is a +1. My next base is b. I have 1/5 times a -1/2. Remember, this is multiplication. So I get a -1/10. So now it's a division problem. When you divide powers, you subtract the exponents. So I'm going to start with a. I have a -3/2 minus 1. What's going to happen is you got to have a common denominator. So this is going to be a -2/2. -2/2 is the same thing as -1. As long as they have a common denominator, you can deal with the numerator. And the numerator is going to be a -5. So that's going to be a -5/2. The next one is b, and that is 2 minus a -1/10. Well, I've got to make this is a fraction, this is not a fraction, so I'm going to go ahead and take care of that now. A negative times a negative is a positive, so I'm going to take care of that now. My common denominator is going to be 10. I don't have to do anything with this one, but this one I have to work with. To get 1 times 10 will give you 10. If I multiply this by 10, I've got to multiply this by 10, so that gives me 20. So I end up with 21/10. So this is going to be 21/10. Now, here's the fun part. I am going to end up with b 21/10 in the numerator, and I'm going to bring the a to the bottom because it has a negative exponent. So that's going to be 5/2. Now you think we're done, but because those are improper fractions, that means we could actually simplify it. And the way I'm going to simplify it is like this. So in the numerator, the way you can do this to make it a little bit easier for you, you're going to see how many times 10 can go into 21. So I know, how can I show you? I know 10 can go into 21 twice. So I'm just going to call that twice. And then it's going to leave me with 20. 10 times 2 is 20. And 20 plus 1 gives you 21. So this is going to be 1/10. I know it looks weird, but think about it. If I broke this down, 10 goes into 21 2 times, and I'm left with 1 left over. Okay, so you could do the math. 10 goes into 21 twice with 1 left over. So this will be 2. That's going to come out of the radical. No stress whatsoever. And then 1/10 is going to stay under it. Okay? I know it looks weird. All right. So this is going to be b squared, b to the 1/10. They're positive exponents. We're happy. Now, a, though, on the other hand, is a little bit more work. I know that 2 goes into 5 twice. So we're going to have a squared and then a to the 1/2. And the reason why that works is 2 plus 1/2. I'm going to make this denominator, whoops, I ran out of room. The denominators, let me just write it over here. It has to be 2. 2 times 1 is 2, and then 2 times 2 is 4. 4 plus 1 is 5. That's where I get the 5/2. So once they have no more fraction, you know that that is out of the radical. So it's okay. Now, I cannot leave I guess I could have taken care of this prior to actually reducing it first, but I can never have a fractional exponent in the denominator. So what I have to do right now is, if I multiply this bottom by a to the 1/2, we all know that 1/2 time or plus 1/2 is 1, because it'll be 2 over 2. Whatever I do to the bottom, I've got to do to the top. Okay? So now in the denominator, when you multiply all of these together, you're going to end up with a to the 3rd power. In the numerator, you have a to the 1/2, b squared, and b to the 1/10. And you cannot reduce it at all whatsoever anymore. That is your answer. So that one's a little bit of work. There's no way, but you are going to be dealing with fractions. There's a lot of different ways we could have done this, but this would be the most, this is just what you would have to do. Okay, sometimes you can twist a little bit of what you would do when you're actually raising a power to a power, and then sometimes you'd reduce it first and not show as much work. But I just think showing as much work as possible is helpful. And how many more do we have? Oh, we still have 10 minutes. Okay, let's go to the next one. This time we're going to multiply. We're going to distribute the r2 to the 5th times the quantity of r3 to the 5th plus r to the 8/5. So when you multiply powers, you add the exponents. So we're going to take this and we're going to multiply it by here. So that's going to give you r. So 2/5 plus 3/5, because when you multiply powers, you add the exponents. That's going to give you 5/5, which is just 1. So that's r to the 1st power. Now you're going to take that and you're going to multiply it by the next one. So it's going to give you a positive r. So that is 2/5 plus 8/5. And that's going to give you 10/5, which is 2. And you can't combine these because one's an r squared and the other one's an r to the 1st. In reality, we normally want the larger exponent written first and the smaller exponent written second. You really don't need to have that 1 on there, so you don't need that. And that is your answer. You're finished. Next problem. Next problem, it is usually when you multiply powers, you add the exponents. But in this case, the bases are not the same. However, you can make them the same if you work for it. So we have 7 to the 2/5 times 49 to the 4/5. You and I both know that 7 squared is really 49. So that is 49 to the 4/5. All I did was just simplify it. Now I have 7 to the 2/5 times, now this is a power raised to a power. So you're going to multiply the exponents. So 2 times 4/5. That's a fraction, that's not. So you get 8/5. So this is going to be 8/5. Now you have a multiplication of fractions, which mean you're going to add the exponents. Sorry, you're going to multiply powers, which means you add the exponents. Okay, because they're fractions, they got to have a common denominator. So my base is 7. So 2/5 plus 8/5 is 10/5, which give you 2. So 7 squared equals 49. All right, next one. You cannot, normally when you multiply powers, you add the exponents, but you can't do that right now. You have to break it down so that the bases are exactly the same. So the number 27, we all know that 3 cubed is 27. The 2 sevenths is on the outside, times 3 to the 1/7. Now, when you raise a power to a power, you multiply the exponents. So 3 times 2 sevenths gives you 6 sevenths, because I'm just going to put a 1 underneath there, and that's the numerators multiplied together and the denominators multiplied together. So that's going to be 6 sevenths here, times 3 to the 1/7. Now, when you multiply powers, you add the exponents. So my base is 3. 6 sevenths plus 1/7 is 7 sevenths, which is 1. All right, so just to show you, 6 sevenths plus 1/7 is 7 sevenths, which is just 1. All right, and then the very last part is this. Write each radical as an exponential and then simplify. So the first problem, we have x to the 3/4. Remember, the index is the number in the bottom. I'm going to hurry up. I'm running out of time, and this is going to be 1/5. When you multiply powers, you add the exponents. So 3/4 plus 1/5. You cannot do that. They have to have a common denominator. The denominator is going to be 20 because 4 times 5 is 20. So in order, what to do with 4 to get 20, you times it by 5. Whatever you do to the bottom, you got to do to the top. So you get 15. Now, whatever you do to 5, you multiply it by 4, it gives you 20. You got to do the same as the numerator, that gives you 4. Now the denominator is 20, the numerator will be 19. So this is going to be 19/20. Let's move to the next one. The next one's going to be x to the 5/2 over x to the 1/3. Remember, when you divide powers, you subtract the exponents. So it's going to be x 5/2 minus 1/3. So 5/2 minus 1/3. Remember, you have to have a common denominator. Denominator is going to be 6. Whatever you do to 2 to get 6, you times it by 3. Times the numerator by 3, that gives you 15. Times this by 2, times this by 2, that gives you 2. The denominator 6, 15 minus 2 is 13. That's going to be x equals, or x to the 13/6 power. And you can leave it like that. Or if you want to break it down even further, because it's an improper fraction, 6 goes into 13 twice with 1 left over. So you could do that if you want to. All right, next one. This is, let's work its way out. So the cube root of x to the 1/6. Okay? Then you have x to the 1/6 over 3. To me, that looks really weird. So 1/6 divided by 3. You leave the first fraction alone, change that to multiplication, and flip the second fraction. So you end up with 1 over 18. So that's going to be x to the 1 over 18. That's just a fraction, so you can leave it like that. Thank you very much. See you on the next problem.